On July 28th, Kilauea produced its 50-second lava fountaining episode since this eruption began. That number alone might not mean much on its own, but scientists at the Hawaiian Volcano Observatory have been counting these episodes with real intent because there's a specific historical number they've been watching this eruption climb toward for months, and it just left that number far behind. To understand why 52 is the number that has volcanologists paying closer attention than usual, you need the full history of what this eruption has already surpassed. Kilauea's current episodic eruption in Halemaumau crater began on December 23, 2224. By June 1st of this year, on episode 48, it had officially broken the previous record for fountaining episodes in a single Kilauea eruption, a mark of 47 set during the opening years of the Pu'u O'o eruption, which ran from 1983 to 1986. This current eruption has now pushed that number to 52 and continuing, with USGS scientists noting the pattern of ground deflation and reinflation at the end of episode 52 indicates another episode is likely. That comparison to Pu'u O'o isn't a random historical footnote. It's the reason this specific milestone matters so much to the scientists tracking it. Pu'u O'o started in a strikingly similar way, a series of episodic fountaining events at a rift vent, before eventually transitioning into something much longer-lived, much more destructive, and fundamentally different in character. That eruption ultimately continued for 35 years, becoming one of the longest duration eruptions ever recorded on Earth. And along the way, it produced lava flows that destroyed entire communities in Kalapana, and decades later, contributed to catastrophic flows in the lower Puna district. The 2018 chapter of that same eruption's story is the part most people actually remember, because it's the most recent and by far the most destructive. Over roughly 3 months that year, new fissures opened miles from the summit in the residential Leilani Estates subdivision, eventually destroying more than 700 homes and reshaping the entire southeastern coastline of the island as lava poured into the ocean. That catastrophe didn't begin as a sudden, unpredictable event. It began as a decades-long eruption that had, for years beforehand, seemed relatively contained until a shift in the underlying magma system sent it somewhere entirely new. That's precisely the historical shadow hanging over any Kilauea eruption that starts breaking longevity and episode count records the way this one has. Here's what normally happens with a Kilauea eruption, and why this current one has already deviated from that pattern in a way worth taking seriously. Most episodic fountaining sequences at Kilauea's summit either wind down within weeks or months as the magma supply driving them eases, or they eventually migrate, sending magma laterally through the volcano's rift zones to erupt somewhere else on the island entirely, sometimes far from the summit. What's different this time is duration and consistency. This eruption powered through its first 50 fountaining episodes in 551 days, averaging roughly 11 days between eruptions, a remarkably steady, almost metronomic pace that has now sustained itself for more than a year and a half without the kind of extended pause or clear decline that would typically signal an eruption winding down. For comparison, many of Kilauea's episodic eruptions throughout the 20th century ran their course within a single year or less, producing a burst of activity before either stopping entirely or transitioning quickly into a different eruptive style. An eruption, still producing regular powerful fountaining episodes a year and a half after it began, on a schedule consistent enough that scientists can roughly predict when the next episode is likely, is already an outlier by that historical standard, well before factoring in the record-breaking episode count on top of it. That steadiness is the first data point building the tension here. A single, unusually long eruption is one thing. An eruption that keeps a strict cadence for over a year and a half, all while breaking a 4-decade-old record for total episode count, is a pattern scientists don't get to observe very often. And it raises the exact question Pu'u O'o's history makes impossible to ignore. Is the underlying magma supply feeding this system stable, or is it building toward a transition into something else entirely? The second data point comes directly from what USGS scientists have said, on the record, about what's actually feeding this eruption. Reporting on one especially large episode, HVO scientist Wendy Stovall described summit magma running underground toward the lower Puna district as much more stuff coming out of the ground. Language used specifically to explain why flows during that historical event moved further from the summit than earlier activity had. That's not this year's eruption, specifically, but it's the exact playbook USGS scientists reference when explaining how a summit-confined eruption can shift into a much more consequential, community-threatening event. Increased magma supply finding a path away from the crater it started in. Like and subscribe if you want breakdowns like this one, tracking not just what a volcano is doing today, but what the historical pattern says about where it could be headed, because that context is exactly what separates informed concern from unnecessary panic. Now bring in the third data point, the one that makes this year's episodes genuinely dramatic, even without any change in direction. Episode 50, on June 27th, produced a lava fountain reaching up to 1,000 feet, roughly 300 meters, into the air from the north vent. Episode 43, back in March, produced the tallest fountains of the entire eruption so far, estimated at 1,170 feet, or 540 meters, sending ash and debris to communities up to 50 miles away. These aren't modest lava flows creeping across a crater floor. They're some of the most powerful individual fountaining events ever recorded at this volcano, happening as part of a sequence that's already broken the all-time record for total episodes. To put those fountain heights in perspective, 1,170 feet is taller than any building on Earth, more than 3.5 times the height of the Eiffel Tower. That's molten rock being launched to skyscraper-shattering altitudes repeatedly as part of a sequence that's still ongoing more than a year and a half after it began. Each individual episode has also carried its own volume of erupted material. One eruption alone in November released just under 11 million cubic yards of lava, enough to fill an Olympic-sized swimming pool roughly every 5.5 seconds, for the duration of that single episode. Here's where it's worth being genuinely precise about what current science can and cannot tell you about where this goes next. Volcanologists cannot currently say with confidence whether this eruption will eventually migrate laterally the way Pu'u O'o ultimately did, continue indefinitely as a summit-confined episodic sequence, or wind down entirely within the coming months. What they can say, based directly on official USGS statements, is that, as of every notice issued through this eruption's history, all activity has remained confined within Halemaumau crater inside Hawaii Volcanoes National Park, and lava has not threatened homes, buildings, or communities on the island. That containment is not a minor detail. It's the single biggest practical difference between this eruption's current impact and the kind of destruction Pu'u O'o eventually caused. So what does the range of outcomes actually look like from here? On one end, this eruption could continue exactly as it has, episodic fountaining confined to the summit crater, gradually building up the caldera floor with fresh basaltic rock episode after episode, eventually tapering off within the park boundaries the way many of Kilauea's past summit eruptions have. On the other end, and this is the scenario Pu'u O'o's history keeps in the back of every volcanologist's mind watching this record unfold, sustained, high magma supply could eventually find a path into one of Kilauea's rift zones, sending lava away from the summit and toward populated areas the way it repeatedly has in past decades, including the catastrophic 2018 Lower Puna eruption that destroyed more than 700 homes. Between those two ends sits the most likely near-term outcome based on current monitoring. Continued episodic fountaining at roughly the same pace, closely watched for any change in the deformation and seismic patterns that would signal magma. Beginning to move laterally, rather than simply refilling the summit reservoir. There's a genuinely uncertain thread worth naming honestly here too. Some volcanologists studying long-duration Hawaiian eruptions have raised the question of whether an eruption sustaining this specific rhythm consists in episodes roughly 11 days. Apart for well over a year, itself indicates a magma supply rate stable enough to eventually support a much longer eruption in the Pu'u O'o mold, rather than the sequence simply petering out. This remains an active area of monitoring rather than a settled prediction, and HVO scientists have been careful not to publicly forecast which direction this specific eruption ultimately takes. Even without any dramatic change in direction, the eruption already carries real hazards worth understanding clearly. Volcanic gas, released during each episode, primarily sulfur dioxide, reacts with the atmosphere to produce VOG, a form of volcanic air pollution that can cause respiratory problems for people downwind, particularly affecting children and anyone with existing respiratory conditions. Tephra, the volcanic fragments and ash produced by these fountains, has repeatedly closed sections of Highway 11, a critical route around the island, and fallen as far as 50 miles away in communities including Hilo and Kea'au. Pele's hair, thin volcanic glass fibers, has been reported settling in residential areas near the park, an irritant to skin, eyes, and respiratory systems, and a genuine concern for households relying on rainwater catchment systems that could become contaminated. So what does this actually mean if you live on the Big Island or are planning to visit while this eruption continues? Check the current Kilauea alert level and Highway 11 status before traveling near the national park, since road closures tied to Tephra Fall have occurred repeatedly and with limited advance notice throughout this eruption. If you live downwind of the summit, particularly anyone with asthma or another respiratory condition, monitor VOG forecasts specifically rather than just general air quality, since sulfur dioxide-driven haze can be locally hazardous even when broader air quality readings look acceptable. If your household relies on a rainwater catchment system, check it after any episode with notable ashfall in your area, since volcanic debris can affect water quality in exactly that kind of system, And USGS has specifically flagged this as a concern for communities using catchment for drinking water. And if you're visiting Hawaii Volcanoes National Park during an active episode, follow National Park Service guidance on eye protection, dust masks, and appropriate clothing, since accumulated tephra and windblown volcanic debris remain a real hazard even from a safe viewing distance. Families living anywhere in the lower Puna district or along Kilauea's rift zones specifically should also keep half an eye on official Hawaii County Civil Defense updates. Not because current activity threatens those areas, but because that's precisely the agency that would issue the earliest public warning if monitoring data ever showed magma beginning to move in that direction. Kilauea has broken a record that stood for 4 decades, and the eruption that previously held that record eventually became one of the most destructive in the volcano's modern history. That doesn't mean this eruption is following the same script. Every USGS notice issued so far confirms the activity remains exactly where it's always been, contained inside the summit crater, threatening nobody's home. But the reason scientists are watching episode 52 and whatever comes after it more closely than they might a routine eruption is that the last time Kilauea sustained a pattern this consistent for this long, it eventually didn't stay contained. Nobody can tell you today whether this eruption follows Pu'u O'o's path or writes its own, entirely different ending. What they can tell you is that the record it just broke is exactly the kind of number worth watching. 52 episodes, 1 record broken, and 35 years of history sitting quietly in the background of every scientist's mind at the Hawaiian Volcano Observatory right now. That's the countdown this eruption has actually been running since the day it surpassed episode 47, and it's a countdown with no confirmed finish line yet, only a historical precedent nobody watching this volcano has forgotten.